Hello, Internet. Today, I want to continue our discussion about the application of artificial intelligence, of explainable artificial intelligence, and include the topic of ethics, and especially after having looked last video on the upcoming EU regulation on artificial intelligence. Today, we're going to look at the American side of the United States of American approach, and there's one specific side I want to show you, Stanford research. So, short summary, in the European document, we had a look that they say, hey, artificial intelligence can provide some key competitive advantages to companies in Europe and the European economy as a whole. Such action is especially needed in high-impact sectors, including climate change, to fight climate change, environmental safety, health, the public sector, finance, mobility, home affairs, agriculture, so a lot of applications in industry. However, the same elements and techniques that power the socio-economic benefits of artificial intelligence can also bring about new risk or negative consequences for individuals or the society as a whole. And then they laid out their concept how to regulate commercial artificial intelligence applications in the European market. They have a three-step approach. They say, okay, at first we have non-acceptable AI, then we have high-risk AI, and then we have low-risk AI application in the market. And I had a whole video done on this paper to explain it. But now let's just jump over the pond and have a look at the US. In the US, Stanford sticks out to me because Stanford helped pioneer artificial intelligence, and now the university puts humans at its center. And this is an interesting approach. Here, an article from the Washington Post dated 2019, Palo Alto. Stanford wants to be at the forefront of a different type of innovation, one that puts human and ethics at the center of a booming field of AI. And you might say, why does Stanford want to put humans and ethics at the center of AI? After having coined the term artificial intelligence, and the university itself created some significant application of AI, like the first autonomous vehicle. Well, there's the new Stanford Institute of Human-Centered Artificial Intelligence in 2019, and this ignited some very interesting view. Here we have an article from Fast Company in August 21, where they say tech industry AI, so the big industry players, have a specific AI that is getting dangerously homogenized. So it's almost all the same. We depend only on a few powerful models, which could have bias and could have other flows that can rapidly spread all over all application, all downstream application. And they say, hey, a careful review in an academic environment could help to reduce the risk for the user, for individuals, and reduce the risk for society and the industrial sector as a whole. And they argue that those foundation models, sorry, my mistake, such as GPT-3, and I did a video on GPT-3 where I called it a large language model, an LLM, you will find in my video library. And they say these foundation models have some real downsides. They create a single point of failure, so any defects, any biases which these models have, any security vulnerabilities are blindly inherited by all downstream tasks, of course. So they start to have the Stanford Institute of Human-Centered Artificial Intelligence. And if you want to find out about this research center in detail, here we have the homepage. I leave a link to you. It is very easy. It is hi.stanford.eu/research. And they have 3 research focus areas. And it is interesting to see the parallel in the topic and in the wording compared to the upcoming EU legislation. First topic is human impact. And they say to develop trustworthy technology. So again, here this wording, You have to trust the technology. Whatever the technology decides, you should trust it. And how is it possible that you trust it? You have to understand how artificial intelligence performs in practice and how specifically it can impact humanity. Exact approach like in Europe. And then they say that the current artificial intelligence system resists explanation or an interaction in terms that are comprehensible by humans. So humans do not understand how artificial intelligence systems work. Therefore, we need explainable artificial intelligence system. More or less the same approach they do in Europe, where they have a little bit under structure, but the content, the core topic is the same. And then the third research topic, of course, is to augment our human capabilities by AI to make work better and more enjoyable. To do this, there's a very interesting report by Stanford University, the Center for Research on Foundation Models. So you have high, and then you have a specific Center for Research on Foundation Models, what I call large language models. And you see a lot of authors from Stanford, heaven's sake. And they published a paper that is highly interesting. And they argue that AI is undergoing a shift with the rise of models like BERT and NLP or GPT-3 for a large language model that are trained on a broad data at scale and are adaptable to a wide range of downstream tasks. Yeah. They go on opportunities, and they show the risks of those foundation models, the technical principles, and the societal impact, the misuse, the inequity, economic, environmental impact, the legal and the ethical considerations of those models. And they say their scale results in new emergent capabilities and effectiveness across so many tasks incentivizes homogenization. And also homogenization provides a powerful leverage, but it also demands caution, as the defects that are inherent to those foundation models, or LLM, are inherited by all the models downstream. And if you have at the top of your pyramid, of your technology pyramid, only 1, 2, or 3 LLMs, and all other tasks in all other industry, from healthcare, education, lifelong learning, medicine, law, vision technology, transportation, if the model at the top has some problems, all the other downstream model will inherit these models. And they want to tackle exactly these questions. And we believe much of the critical research on the foundation models, on these huge models done by the big players like Microsoft or Google, will require a deep interdisciplinary collaboration given their fundamentally socio-technical nature. So they constructed a really interdisciplinary team crossing a lot of disciplines in Stanford University. And I think this is a highly interesting approach done by the research community in the US. But let's have a look at this report on the opportunity and risks of foundation models. Because I want to show you that more or less the concerns about this unexplainable AI, this black box AI, is almost identical either on the European side of the pond or on the American side. And as always, this is something I would like to point out a little bit later, we start at the beginning. For heaven's sake, the beginning is here. So we have this report by Stanford University on the opportunities and risks of foundation models, what I call LLM. You will find them in my videos described as LLM. I did I think 3 videos on LLM. So if you're interested in the technology behind LLM, you will find it in my video library. And then they start here and they have a look at the language sector, the vision sector, the robotics sector, and also some sectors in the future like reasoning, interaction, and philosophy of understanding for AI. And of course, they focus on industrial commercial applications. And they have here three sectors. The first is healthcare, where you have the interface for care providers, the interface for patients in the areas of biomedicine, personalized medicine, drug discovery, but also clinical trials. And they have a very nice argumentation going on here, where they say, okay, we have our input data on the left side. In the middle, we have this miraculously trained model, huge model. You need almost a cloud compute center, a supercomputer in the cloud for this model to train this model. Costs millions or tens of millions of dollars to develop and train the model. And then you have all the costs to deploy this model. And of course, what you want to achieve here is better healthcare, better interface for care providers, better interface for patient, question answering, assistive care, community health, and prevention, of course. All done by a supercomputer in the cloud that runs this foundation model provided, let's say, by Microsoft. So here we go, and you see healthcare is one topic. Law, they've chosen to present to, if you want to see the logic reasoning given the law sector. And of course, a huge sector is education, where you have your textbooks, your pre-recorded video lectures, your examinations, and you have your discussion forums. And of course, the content, math, physics, chemistry, science, art, language, drawing, drawing. And you have then this multimodal data sources, the training. Again, a supercomputer runs these foundation models. And then you have the task and goal that you achieve that you can provide as a service to your user, to your students, to your pupils, whatever. And you see here this commercial application side is very tempting. And just to remind you, you see here the significant, I don't want to call it a bottleneck, but here a singular risk, a singular point of failure. And if you remember in my last video, I showed you the explainable AI business case, that you have the government, the regulator, the society who provides all the data. Then you have this big cloud company. Think about it as Microsoft, who can afford to invest 100 million, 500 million, $1 billion for a cloud supercomputing center, where they can afford to develop the AI model. They invest heavily in very intelligent people who develop very genius models, but those models are, of course, developed for specific tasks. And then they sell this model. And you, as a company, a classical industrial company in your industrial sector, you say, hey, now I want to apply some of this beautiful, miraculous AI for my business. I want to have a new revenue stream. I want to open up new growth paths in my future of my company. So what you do, you buy a model. And you will find out that this model that you buy to perform, let's say, the task of a call center or of some informative center, you need to buy this model. And this model, of course, Microsoft will be happy, I suppose, to sell you, a commercial company, this model that they develop. But you will find out that for your specific needs, for your specific industrial sector, you will need some adjustments to this model. Maybe you will train your model on your specific company data. So what you have to do, you need the infrastructure to run the model. So you lease the computer infrastructure from this big cloud company. Again, here Microsoft, because who does not love Microsoft or the Office package? Another topic. So you lease the computer infrastructure in the cloud, a supercomputer center. And then to do these specific adjustments, you need to go deep into the model and maybe adopt the model itself and not just have to run the training run for the model on the new input data. So if you have to develop the model further, you need the resources, the professional people who are able to optimize the model for your specific adjustments. And then, of course, when the model has been adjusted, the model has been trained on your data, on this infrastructure here, they will be able to sell your specific tailored model for your company. And if you want to implement this model and you have your business processes and you say, heaven's sake, how do I integrate this in a data-aware team structure? Well, guess what? They have a professional team that you can rent or you can buy for the temporary team assignment. So what you depend on is you lease the computer infrastructure by this big global player. You have to develop this model that they own and maybe is not open source, that it is adapted to your needs. Then this model is trained, of course, on this infrastructure. Then they sell you the model, but to deploy the model, you have to lease again the computer infrastructure because this model should be running 24/7 for you to generate more revenue. So you have the infrastructure, you lease the development, you lease the training you have to pay for, the model, your specific model you have to pay for, and you have to pay for the integration in your business processing. So you see that some people argue, hey, wow, there could be some dependencies between these two blocks. And this is what they look here in detail in the Stanford report on the opportunities of LLMs, of foundation models, like they call it. And you can see this very clearly, but let me go to page 123, if I remember correctly. Yes. In the Stanford report on opportunities and risk of foundation models, you should always think about the configurational problem, because either you have one model, and this is where the industry more or less is going for. You have huge LLM models developed by cooperation between Microsoft and NVIDIA. Imagine, even Microsoft has to cooperate with NVIDIA for the GPUs. So you have one model that can do everything. In this model, you have input data from, I don't know, all of Twitter, all of Facebook, all of Wikipedia, all subtitles of all YouTube videos, all available digitized books, all I don't know what. Yeah? In the latest LLM, you have 1.6 trillion, yes, not billion, but trillion BERT tokens in the model. So you have at least, I don't know, up to between 10 trillion and 100 trillion sentences in your input data model. And of course, you have to have this huge amount of input data because you have one model for everything, for physics, for chemistry, for environmental concerns, for the health sector, for the finance sector, for the news sector, for personal communication. So one huge model, and guess what? There are only a handful of global players that have the infrastructure, the cloud supercomputing centers that can afford to run this model. And this is also one point that Stanford makes. Hey, we as research, we as academia, we have to have access to be able to run this model in order to understand it and to figure out how we can optimize it so that it respects our rights, our human rights, our freedom, and that the harm that this model could provide in the worst case is reduced. Or you have the approach that is interesting, that for each task, for each specific task, let's say vision, you're driving your car, you need a vision recognition system, a distinct model mechanism is used to produce the behaviors, the decision, the analytics, whatever. So you have here in the first stream, I don't know, vision technology. The second stream could be speech, text, NLP, the BERT models you apply for clustering, question answering. Then you have a model that is, if you have a knowledge graph that is optimized for knowledge deduction, for a knowledge graph embedding in a topological space. So you see, maybe you should analyze if you need a one model for everything, or you have many specialized models, smaller models, easier to train for a specific task with a technology that is really experienced for now 2, 3, 4, 5 years maybe even, so you know a little bit about the shortcomings and the opportunities and the drawbacks of these systems. And then you combine this system to perform an overarching task. Very interesting point. But I can see right now we're already 20 minutes into this video. And I just want to show you Stanford. Very interesting. This study on the opportunities and risk of foundation model, on the ethics of foundation model, how the future of explainable AI models, how this is the future, because you as a user or you as a provider of an AI system, at least given the European Union, you as a provider, you have to provide an explanation how the system is working, what are the risks of your system you bring to the European market, you deploy in the European market in the member states of the EU, and you are reliable, and you have to take precautions that you do not risk anything with your user, you do not harm anybody, you do not have a negative impact on the human rights of your user. I say thank you for listening. This was an explainable AI video on the American side of explainable AI at the beginning of 2022. And I hope to see you in the next video.